In this video, we are talking about how to do dilutions and dilution calculations. So dilution is a pretty simple process. You've done it a number of times before in your life. It's simply the process of lowering the concentration of a solution by adding more solvent. And so from your perspective, you've probably done this a number of times anytime you cook or you make beverages or anything like that, and it's too sweet, too sour, too spicy, too whatever. You add water or you add cooking stock or you add something to it to help to dilute the flavor. Now, what we have to understand about dilution is that dilution is only adding more solvent. It's not, and by adding more solvent, we're getting more total solution, we're getting a lower concentration. We're not actually changing the number of particles that are in the solution. So if you look at these three solutions, each successive solution is more dilute than the one before it, but yet the number of particles inside of the solution hasn't changed. They've only spread out more. And that's a real key to dilutions in general. Now, let's look at some key terms for dilutions. The first is the idea of a stock solution. A stock solution is simply a concentrated solution. And from that concentrated solution, we make more dilute solutions that are lower in concentration. And a standard solution, which can be different than a stock solution. A standard solution is a solution whose concentration we know quite precisely. So how do we figure out how do we figure out dilutions from these standard solutions or from these stock solutions? Well, the process is actually pretty easy. We're going to take advantage of the fact that when we dilute, the number of moles of each stays the same. And so if I take the molarity of my stock solution and I multiply by the volume of my stock solution, that combination, molarity times volume, will give you moles. And if I do that to both sides, these values will be equal to each other. Now, most times we are thinking about this from a perspective of molarity, but it is possible that this concentration solution equation will work in other scenarios as well. So it's often that we will see this solution, this equation rewritten as C1 V1 is equal to C2 V2. And the reason why is we don't actually need molarity. This will work for any concentration unit, percent by mass, parts per million, molarity, and any of them. The other thing that we don't need is that our volumes here just have to have the same unit. So they can be liters, they can be milliliters, they can be whatever, but they have to be the same. I don't have to use liters. I can use whatever I have. So more often than not, we measure the solutions in terms of how many milliliters of solution we have. And that's fine. We can use that here because if we do our algebra in the end here, if I have milliliters here and milliliters here, then when they divide, the milliliters will cancel out anyway. And same thing for the concentration units. If I have concentration here and concentration here, so long as the same concentration unit, the concentration units will cancel out when we do the division, which is why this more universal equation here is kind of the more well regarded. So let's take a look at an example. Hydrochloric acid comes from 12 molar stock solution. What volume of stock solution is required to make 500 milliliters of a 0.145 molar dilute solution? Well, using my dilution equation, M1 V1 is equal to M2 V2. I know M1. M1 is 12.0 molar. It's the stock solution concentration. I don't know what V1 is. That's what we're trying to find out. But on the flip side, I do know that M2, I want this to be 0.145 molar, and I know V2, I want 500 milliliters of the stuff. So if I set that up into my equation, 12.0 molar multiplied by V1 is equal to 0.145 molar multiplied by 500.0 milliliters. If I set up my algebra, I'm going to want to divide each side by 12.0 molar. And when I do so, my 12 molars will cancel on the reactant side. My molar concentrations will cancel out on the right-hand side. And so I'm left with V1 is equal to 0.145 multiplied by 500 divided by 12.0 to three significant figures. I need 6.04 milliliters of stock solution. So dilution equation problems are really, really easy to set up, really easy to do calculations. The algebra always flows from this multiplying and dividing sense. In our next video, I will look at another way that we can apply equation that is very similar to this to actually solve certain types of problems involving aqueous solution. We know them better as titrations. So until then, have a good day.